welcome everybody. Great to see members and some visitors, non-members. Welcome, and also welcome to all those who are on Zoom tonight. I know we do have quite a few people on Zoom, both members and non-members, so welcome again. For those of you who don't know me, my name's Iraqi Childs. I'm the immediate past president. And this evening, our current president couldn't be here, so I'm standing in as chair for him tonight. So this evening, we have a very interesting topic and a very interesting speaker. Dr. Xavier Leon is from the University of the Sunshine Coast, where he is a senior lecturer in geography. And Xavier's expertise and interest sort of span a lot of areas to do with, I suppose, coastal matters. He has worked on the Great Barrier Reef, but also parts of the Pacific, Papua New Guinea, and Vanuatu, was it?
Fiji.
Fiji, as well as down the east coast of Australia. And tonight he will be focusing, of course, on southeast Queensland. As we've all experienced this past year and part of this year, we've had 3 La Niña events and massive floods in many parts of our country. So I think Xavier's talk this evening will be very topical. And again, if you have questions, at the end of Xavier's talk, we'll have a Q&A session, and that also enables the people on Zoom. If you would like to put your questions on the chat, we can answer your questions. And it is being recorded this evening, so could I ask you please to make sure your phones are turned off or turned to silent. So without further ado, please welcome Dr. Xavier Leon. Thank you.
Thank you very much for that, and thank you for being here. It's always great hearing face-to-face talks. I miss that so much. Yeah, unfortunately, one of the byproducts of the pandemic was that we stopped giving lectures at our uni. So I really crave human contact every now and then. And especially when I talk coastal stuff. So I will try very hard not to move that much. Although the first ever lecture I gave at uni, it was on biogeography, which I don't like. I never liked. And I was literally behind a computer all the lecture. And all the students were like, please step away from the computer, because you are hiding behind, and it was true, I was hiding behind the computer. So since then, my mission was to step away from the computer and engage more, which now I've become very addicted to. So I do move a lot, and I try to kind of like move all around, but I know my limits, so kind of like I will move from here to here, and that's all I do. So, okay, just doing this a little bit over. Okay, that should be fine. So first, so this is not working, so I'll just use this one, which is not working either. I won't freak out. I'm used to this. Technology, I work with technology every day. Yep. There you go, thank you. So first of all, I'd like to acknowledge the traditional custodians of the land in which we're meeting, and extend that to across Zoom. So wherever you are, I want to recognize the continuing connection to land, sea, and community, and I pay respects to elders past, present, and emerging. So I originally come from Peru, South America. So El Niño has a lot of, I have a lot of connections with El Niño, because originally the term El Niño, which means the kid, comes from, or was first recognized by fishermen talking about this strange event happening around Christmas. So around that time, El Niño, Jesus, was born. And they noticed that around Christmas, they tended to get more warm water fish, especially like mahi and all of these tropical species coming further down south. So they were like, oh, this is El Niño, right? And that's where it comes. So this was back in the 18th century. And that's basically where the term was coined. And for us in Peru, El Niño means a lot of rain and very destructive rain, very similar to what we experience on the East Coast with La Niña, right? So La Niña back in Peru is actually dry and cold as opposed to here. And that's mainly because we have these strong kind of like trade winds. So on the left, on your right, we can see a typical El Niño event. And that's where these trade winds, sorry, on your right, this one. That's what we see El Niño. So the typical trade winds that blow to the west, they weaken. And that kind of like generates many things. So one of those things is that the strong upwelling we have off the coast of South America weakens. So that really productive cold water upwelling on the coast kind of like stops. And those warmer currents from the north penetrate a little bit down towards the south of South America. So that's kind of like your typical El Niño. For us on the other side of the Pacific, so here, we get these kind of like cooler than normal conditions and a little bit drier. The opposite happens when we have a La Niña event, which is on your left. That's when the trade winds actually strengthen more. So all of that kind of like pushes, if you can think about the Pacific Ocean basin, all of that warm water on those winds just pile up towards this coast. And that generates an increased convection. So we get warmer conditions, especially in the tropics, and above average rainfall, right? So that's exactly what we experienced the last few years. Just a pause. My accent, right? So here's the thing. As I move through these slides, I will get more and more excited because I'll be talking about really amazing stuff. So I will be speaking faster and faster, and my accent will just degenerate into this block, right? So if I start doing that, please stop me and just go like, come back, right? And open your mouth. But if I do that too much, then I become really boring and you all will fall asleep. So we don't want that. So I will put it somewhere in the middle. Now, throughout this lecture, I will also be talking about how things are really complex and nothing is simple, because that's life. And we all know that. So on top of everything, we need to understand that there's different flavors of these oscillations, right? So we might have like your typical El Niño, and that's what we called the Eastern Pacific, or the canonical Eastern Pacific El Niño. And that's when usually the waters closer to South America get warmer. But recently, we've been experiencing more and more of these Central Pacific El Niño. So the center, the middle of the Pacific gets warmer. It kind of like shifts a little bit to the west. And these are sometimes called the Modoki El Niños. So recent research have shown that there's a tendency towards more of these Central Pacific El Niños coming in the future. Kind of like that's where we're moving. And of course, the different flavors of El Niño have different effects. And I will touch on that in a few slides. So how many of these El Niños and La Niñas we've experienced? And that depends. And you will hear this from me many times. That depends. That's my favorite phrase. Like every time a student asks me, whatever, I go like, it depends. So it always depends. It's not simple. But we can go for different definitions of El Niño and La Niña, which might be problematic, actually. To put that into context, only a few weeks ago, as in probably 2 weeks ago, maybe 3 weeks ago now, off the coast of Peru, there was an increased temperature on the ocean. So, but because it was so close to the coast, that wasn't caught on the El Niño, La Niña definition radar. So it wasn't officially announced, even though it produced very intense rainfalls in Peru. Intense enough to like break down the main highway and take a few cars in the process, and activated many gullies which were inactive for years now. So it was quite destructive, and no one saw it coming. And that's because it's kind of like a new El Niño. So now we have they call it a coastal El Niño. So we have Central Pacific, Eastern Pacific, Coastal Pacific El Niños, and all of them have slightly different effects. So super complicated. Anyway, let's go with the standard definition of El Niño and La Niña. And here we see a record of events since the 1950s, all the way up to this year. So on the top here, we have El Niño events, and there's 2 thresholds, or 3 thresholds. So this one here is anything that goes above that line is considered a weak El Niño. Everything that goes above that line is a moderate El Niño.
We're not seeing.
Can you point?
I'll do both. So yeah, you have a weak El Niño, a moderate El Niño, strong, and then your very strong El Niños. So on red here, you can see the strong and very strong El Niños. On the other side, we have our La Niñas. Again, weak, moderate, strong, and very strong. So on the red numbers there, you can see the periods where we had strong or very strong El Niños. And on the blue ones down there, strong and very strong La Niñas, right?
Yeah.
So, of course, this depends on what definition you're using to classify El Niño or La Niña. So sometimes you might hear different periods or different, but let's go with this one. And what we're seeing is that there's 2 patterns here worth mentioning. One is that after strong La Niñas, usually we get strong El Niños. That's one pattern. So in most cases, after we have this huge fluctuation towards a La Niña, it bounces back to El Niño. So given that trend, we might expect, and we are actually expecting and watching a potential El Niño forming later this year. That's one interesting one. The other one is, of course, this whole triple La Niña, these triple dips, right? And they're not that common. We've only had 3 of those triple La Niña events since the 50s. So, and some might even argue that that this one wasn't really, or sorry, this one wasn't really kind of like a triple one. So depends on the definition, but let's go with that. Let's go with 3 prior to this last one, the one we just experienced. They've only been 3 of those. Now, some people might say, well, that might be climate change, or maybe not. We don't know. We cannot know because our records for El Niño and La Niña don't go too far back into the past. So we cannot really see a pattern yet emerging. There's some evidence that we can get from historical data like oral cores and similar, but we really don't know what's exactly going on. And that's why when I was growing up, I remember hearing that El Niño and La Niña came every 4 years. So then, you know, people were like, okay, it's been 4 years, what's up? Then kind of like that changed to, no, it's between 3 and 6 years. And then, so it keeps changing. And that's because our record keeps getting bigger, so we can now get better patterns, but it's complicated. It's not that easy. And if we want to determine which one of these events are Modoki, El Niños, or not, that even gets more complicated. But yeah, but let's just go with it. And in general terms, let's see what does this mean, especially for our coasts, because that's what I'm talking about. So according to BOM, there's three things that we should be considering when it comes to coastal impacts. That's we get stronger trade winds, and waves come from wind. So we should expect kind of like more energy, more waves. There is higher chances of getting tropical cyclones. And the third one, I would just put it there, but I won't talk too much about it. But sometimes with La Niña events, we get a drop on sea level, a localized drop on sea level rise, on sea level, not sea level rise, sea level. Now, I won't talk about that because the other ones are way more important. So increased winds and potential more cyclones. So in general terms, what we should expect from La Niña events on the East Coast, on the Southeast Coast especially, is an increase on wave power, an increase in tropical cyclones, and also a change in that wave direction, which is very important when dealing with coastal changes. So on a very recent study, as in months, this study has been out for only a few months now, the authors used satellite imagery for like 30 years plus to look at changes on coastal changes across the whole Pacific basin. And what they found was very interesting because first, they confirmed that yes, for Southeast Australia, there is an increase in energy, wave energy during La Niña events. So we're confirming that. And secondly, that erosion around the Pacific basin, even though this is a very coarse analysis, it showed some patterns. One of those, very relevant for us, was that during La Niña events, especially Southeast Australia, was an erosion hotspot. So during La Niña events, we've observed higher than normal coastal erosion. But that's very coarse, and that's kind of like Southeast Australia. So that includes all the way from New South Wales to Queensland. So let's refine that a little bit. And of course, we have more energy, so more erosion, but also that wave direction changes. And that's key because, and this was identified many years back, where many scientists observed and termed this switch in beach position. So this beach rotation with these ENSO cycles, so La Niña and El Niño. And basically what they observed was that during an El Niño event, the coast will rotate clockwise when dealing with this compartment, like these pocket beaches, right? So beaches that are enclosed by two headlands. So this is the case of Narrabeen down in Sydney. And you can see after an El Niño event, the shoreline kind of like switches that way. So you see more erosion there and more accretion up there. And then it comes back with La Niña, changes the other way. So that was very interesting. So they produced this conceptual model of how this happened. And basically they were arguing, or they were proposing, that this was because of changes in wave direction, and that drove longshore drift, basically. So those longshore currents moving sand up and down. That has been refined since. And even though that wave exposure explains a lot of that variability, there's other factors to include. But anyway, the bottom line there is that changes in wave direction because of ENSO cycles will change the orientation of the coastline on those kind of like pocket beaches. Now, I told you that things are always more complicated. This is an example of that. On this other paper, the author showed that the predominant direction of waves changes from an Eastern Pacific El Niño and a Central Pacific El Niño. So we can see here that, for example, during a Central Pacific El Niño, we get most of those waves come from the northeast. But during an Eastern Pacific El Niño, those waves come from the southeast. So there's a lot of difference there, and that has huge implications for change. So depending on what flavor of event we are dealing with, we might expect different changes. Okay, what about tropical cyclones? Because we are told that we should expect more than average, higher than average tropical cyclones. And of course, that's the consensus, but in reality, it's complicated. So here we see a map showing the probability or the number of cyclones that we might expect during an El Niño event. So you can see that they are spread more to the east and to the west of Australia. During La Niña, you can see that that comes closer to coast, meaning that there are higher chances of getting more cyclones closer to the coast, which of course have huge implications when it comes to coastal changes. But it's not just about the number of cyclones. It's also about the type of cyclones and the type of event. So here we can see a figure showing us severe cyclones versus non-severe cyclones. Because of course, if you have a cyclone which is way offshore and it just goes really quickly, that's the only thing about that is that surfers are going to be very happy with waves, right? And there's no erosion. But if we get a cyclone close to shore, which is very severe, then no one is happy. So think about Yasi, for example, right? No one was happy with that. And unfortunately, the climate models suggest that these severe cyclones will increase in the future. So we're not yet sure about the frequency, but most models, most projections are forecasting less cyclones, but more severe. So when it rains, it pours, basically. That's what the models are forecasting for the future, which is not great for coast. But again, this is very, there's a lot of uncertainty here. So and it's good to think about this probabilistically, right? So La Niña will increase the chances of cyclones. That doesn't mean that we're going to get more cyclones, as we didn't over the last 3 years. Unfortunately, a lot of people do not think probabilistically. So when someone like me goes out and talks about that La Niña might bring more cyclones, and then that doesn't happen, then people think I was wrong. When in reality, I'm just talking probability. So if I say that there's 80% chances that we're going to see more cyclones during La Niña, and it doesn't happen, that's because there were 20% chances of that doesn't happen, not happening, right? So sometimes it's hard to think about probabilistically, but that's how we need to think about. So that's a setting. That's a theoretical setting. Now let's go on to more fun stuff. Let's look at what I observed the last 3 years. And it was quite convenient because, well, I won't say convenient, but quite interesting because from COVID, or because of COVID, a lot of my research, which tended to be on those beautiful places that were mentioned previously, I had to ditch those and just focus. I couldn't travel. I couldn't, even coming to Brisbane was an issue. Like literally, we couldn't even drive like to Brisbane. So I moved most of my research to where I live, and I live around Noosa. So a lot of my research just focused there. And I fly drones. That's my tool of choice. That's what I use to measure changes and measure the topography. So I've been lucky enough to be monitoring the last 3 years quite intensively. So, and not only me, but sometimes I bring my son, Koa along. He's good for scale as well when I take photos. Yeah, and also I had the pleasure of getting closer to community groups, which has been a very nice experience as well, because I cannot measure all the time everywhere. That I learned the hard way. So let's first look at what waves did during these last 3 years. So based on this buoy just off North Stratford Island, and let's focus on that period between a strong La Niña, El Niño, sorry, in 2015 to now. So let's focus on that period, 2015 to 2022 or 2023, for that deep water wave buoy. Okay, so that's how it looks. That's 2015. You can see the direction the waves are coming from, and those colors show the power. So the warmer the colors, the more energetic those waves. 2016, 17, 18. Now we go on to La Niña. So did you see that? Yeah, more waves coming from that sector, more waves coming from the southeast, more powerful. 2021, even more powerful from the southeast. 2022, a lot of power from the east. Yeah, that's what we were expecting, that change in direction and increase in power. So 2015, El Niño. 2022, bang meeting La Niña, right? And you can see that shift in both direction and increase in power as we were expecting. But that's deep water, right? So that tells us half of the story. Now, that's just a fancy animation I had, so I just use it because it looks nice. But here you can see that buoy. So that's a deep water buoy. That's the one we just saw. That's off Stradi. And then you have these shallow water buoys. But let's focus on that. And let's run a wave model to see how that wave transforms from deep water to the near shore, because that's what we are interested on. So this is a model looking at waves coming straight from the south. Big waves, but from the south. Red colors or warm colors are high energy, and greenish colors are low energy. And you can see that most of the energy just goes straight past, goes straight north. And if you are a surfer, you will be very frustrated with these type of events, because there's a lot of energy there that just goes past the coast. And you can literally, if you ever have the chance of being around a big southerly event, swell event, and you look at the horizon, you will see like this, and literally this wave just marching past, which is a waste. Now, if we look at waves from the east, right? All of that energy now is hitting straight to the coast. So very different. So it doesn't matter how big you get those southerlies, all of that energy is probably not going to make it. But if you get like moderate easterly events, a lot of energy goes in. So let's look at that buoy. That's shallower, right? That's closer to the coast. So that's going to tell us a better story. That's 2015. That's 2022. So you can see the increase in power goes almost twofold, right? So during a La Niña, we're seeing an almost twofold increase in wave power. And that's a lot. And that has a lot of implications for coastal change. The other thing, which is very interesting, is the number of storms, because you remember, like from La Niña, we should expect more storms. This is El Niño. We only had 2 storms, and a storm is defined here as any event that is more than 3 meters. We have 1 normal storm and then 1 huge storm. That's El Niño, La Niña. So this is, sorry, this should be 2022. 6 storms during 2022. Not as big, but very constant all the time. Again, if you were a surfer back in 2022 last year, you had a lot of fun, right? It was non-stop surfing. It was really good times. Really good times. Anyway, so let me zoom out a little bit and talk about coastal morphodynamics. And I know this is a mouthful, but it's quite easy and quite straightforward concept. Basically, what coastal morphodynamics tells us is that you have the morphology, so the beach, and then you have some processes, so waves and currents and things moving sand around. And these two are constantly interacting, and they modify themselves. So there are mutual adjustments. So waves will change according to the morphology, according to the beach, And then as a beach changes, they will change the waves as well. So there's these feedbacks around. And that's very important because if we look at, and this is for any complex system, but we have a few things that are key to understand complex systems like coastal systems. And those are those feedbacks, right? So we might have negative feedbacks trying to hold that system into equilibrium, right? But then we also have positive feedbacks moving away that and pointing it towards a trajectory. So a vicious cycle, right? So if you have erosion and then you have more waves, then you will have more erosion. And then more waves will be even more erosion. So you get into this positive feedback loop. And eventually, you get those negative feedbacks kicking back in, reestablishing some sort of equilibrium. The time that takes for that system to come back to some sort of equilibrium, it's called the relaxation time. And that's key, because if that you don't have a long enough relaxation time, then that system might be pushed towards another state. So if you have a lot of storms, you don't leave enough time for that system to recover. And you might push that system towards a chronic erosion state, for example. So with a La Niña, when we have many storms, even though they're not massively big, we might be putting that system into a lot of pressure. So let's look at how the beach actually changed on these sites. And again, those sites are highly biased because my house is just somewhere there. So it's very easy for me to measure those sites. And those two are quite interesting. And that's why I'm including those there. So first, let's look at how might beaches around headlands might protect, because they're quite very different from open beaches. So we have this process, which is highly complex, again, called sediment headland bypassing. And I've been lucky to have working with a PhD who has been looking at how sediment bypasses Nusa headland. And what he concluded based on our studies was that it depended on that wave sequencing. So if you had southeast waves, big ones, they would push that sediment around the headland and put it there. So that sediment won't go all the way around. It would just stay there. And from anecdotal information, what I heard the last few years was that sand there was the highest it's been for 30, 40 years. So people that dive there have never seen that much sand. And then when you get these easterly and northeasterly waves, they will push the sediment around the headland. So you will get a lot of sand moving around. And from anecdotal information, from personal surfing experience, that was happening non-stop for the last 3 years. You can see this comparison of images. This is Little Cove, just around the corner. And you can see this is 2016. The beach wasn't even there. There were just rocks there. 2022, there was so much sand that lifeguards had this ongoing competition that has been going on for like 50 years. And that's like how far up they can drive their little buggy thing, right? Last year, they broke the record. So someone, I think they drove it up there, something like that. A lot of sand. You can literally, on a low tide, you can literally walk all the way. For surfing, that was marvelous as well. Like the waves on this area were great. But anyway, a lot of sand was moving around. So we got a lot of sand. Now, let's move to Point Cartwright. Similar setting, you have a headland, and you also have these headland bypassing processes. So based on a study back in 2017, after the training of the Mulula River, they were kind of like estimated that on average, they had 10,000 cubic meters per year moving around there. But during these years, they had a lot of sediment moving. And that's a big issue because shoals will just close the entrance, which both people don't like. Surfers like, both people don't like, right? So then if we look at these years closely, guess what do we find? All of those years were La Niña events, strong La Niña events. So every time we have a La Niña event, we have a lot of that sediment bypassing. So this study was before this last triple La Niña. So what happened during these last 3 years? It was actually really bad. It was so bad that they had to kind of like dredge that shoal constantly to allow boats to go in and out the Mooloolah entrance. Really bad. So again, we're seeing the same pattern where we have a lot during La Niña periods, we have a lot of that bypassing. So those are compartments, right? Or beaches on the north of headlands. Now let's look at the open beaches. This is Burgess Creek, just south of Sunshine Beach. And this is quite interesting because you have this little creek there and it moves a lot, This is 2020, 2021, that's like 275 meters. It moves very quickly, moves a lot. But it was very interesting that during 2022, just from January to May, the creek moved northwards, so close to the David Lowway that people actually started caring and listening, right? So council became very nervous because of this, right? To the point that they had to push this creek artificially because it was getting too close to the highway, which is the only highway really connecting the open beaches to Noosa. So again, we're seeing this very complex behavior. Marcus Creek, just south of Burgess Creek, April, June, January, it's pretty much the same. So 2022, and then we go into 2022. A lot of storms from the east, not huge, but a lot of them. And finally, we get to February. So you see there's a little bit of erosion on that dune. So you can see that dune scarp. After that, it just went back a lot. And then even more, right? We head south of that to Peregian Beach. There's no creek here, it's just an open beach. Same thing. During that same period, we saw the shoreline retreating 12 meters and that dune being eroded 1.5 meters. And that wasn't even the biggest change. Like after this, I measured like 3 meters of dune, like vertical erosion, and up to 20 meters of shoreline retreat during 2022. So a lot of movement. Which, let's finish with Bribey because we all know what happened in Bribey. And of course, the shoreline there is highly dynamic. So these are all the years there, highly dynamic, but kind of like, and it's been chronically retreating over the years. And most of those retreats coincide with tropical cyclones. Every time there's a tropical cyclone, retreats even more and more, to the point that we got to 2022, tropical cyclone Seth came, and we all know what happened. This was just before that, 2017, it was already pretty damaged, was pretty low. I surveyed that, and the elevation was 0.5 meter. Seth pushed the water up 1.7 meters. So that was a lot of water going over that and just pushed and breached Bribey. Okay. So we know what La Niña brings. We know that we're going to have more cyclones with more La Niñas. Sea level is rising. More storms with more La Niñas. More people every day comes to the coast, especially post-COVID. So how do we manage all of these issues? So we know La Niña brings erosion, a lot of erosion. How can we manage this? Not easy, but I've come here with solutions. So I actually have 3 solutions I want to share. First of all, let me talk about the current coastal management, especially around Noosa, which is such a valued piece of coast. And right now, currently, what council does is they just pump sand from that end, and they just pipe it up and nourish it on the other end, and main beach. So they just literally recycle the sand, which has worked great. This is 1985 all the way to 2019. You can see the beach used to be on chronic erosion, and since the nourishment, it's now okay, even though it has some dips and peaks, right? So if we zoom in closer, we can see that shoreline position, and we can see how council generally is very reactive. So every time there's big erosion, they just pump a lot of sand, especially after big erosion, and this was the most recent pumping of sand. Now, if we overimpose the ends of cycles, we can start seeing some trends. So we can see strong La Niña, moderate La Niña, strong El Niño, and this triple La Niña, which was kind of like moderate. So after this strong La Niña, moderate La Niña, there was a lot of erosion in Nusa, as expected because of those easterly storms and all of that extra energy. So we can kind of like expect some erosion happening after this triple La Niña, but it's not that simple. So remember this thing about the sediment bypassing. Well, easterly waves actually move the sand around. So we need those waves to actually move that sand. So if there is sand, it will get moved. And it takes 6 months to a year to go from this top to main beach. So we need those easterly waves. The problem is, like, if we have too much of that and we don't have enough sediment. So if we don't have those prior southeasterly waves put in the sand there's nothing to transport, those easterly waves will just erode. So it's basically that sequencing, right, that we need to worry about. So it's not simple, but yeah. And of course, we can see all of these big dips there of triangular high, not within La Niña events, right? And those are usually related to tropical cyclones, and they are random. We have cyclones during La Niña, during El Niño, during neutral conditions. So it doesn't matter if we are on La Niña or El Niño. If we get a cyclone, there's going to be heaps of erosion. And this was Tropical Cyclone Oma, 2019, the last kind of like moderate cyclone that hit Nusa. We surveyed that and we saw that on the literally 40 minutes, 10,000 cubic meters of sand were washed away. So cyclones do, and Oma wasn't even a big event. Like it was the most recent moderate one, but it wasn't even big. So when there is a cyclone, we can expect a lot of erosion happening. But we cannot predict when they will come. So there's not much we can do. So here are my solutions. There's 3 of them. The first one, of course, is that we need to map, monitor, and model these processes. Because if we don't, then we don't know what to expect. So, and we cannot even understand why these things are happening. So it's not about just being reactive, as coastal management these days tend to be. We need to be more proactive, and we have the tools, so we can start modeling this and predicting what might happen during La Niña events. We know what to expect. So this is imperative. But again, the beach and the coast is very big. So one person or a team cannot cover the whole thing. So my 1.5, so 1.5 solution is bring everyone else into the party. So citizen science is a great resource that we need to tap more into. There's a few initiatives. So CoastNap, I don't know if you're familiar with CoastNap, but it's literally a cradle where you put your phone, take a photo of the shoreline, and then that gets processed and we get a shoreline, so we can monitor how that shoreline moves. Very simple concept, very efficient. And then more recently, I've been trying to do this one called Coast 4D, where you take your phone, you put this antenna thing, and then you can survey the area on like the beach on 3D. And so we can start looking at volumes and how they change. So bringing more people to do this empowers local communities, but also provides the data that we so importantly need. So that's my solution number 1. Solution number 2 is, of course, we need to manage those sediment budgets. So it's not about protecting the coast. It's not about protecting infrastructure necessarily. It's about managing the sediment budgets, because we know that that line of defense, the beach, is very efficient. And everyone loves the beach. So it's a win-win. So we need to, when required, we probably need to use nourishment. So this is just after Tropical Cyclone Oma on May Beach. So yeah, sometimes you just need to re-nourish. It's not a sustainable solution, because you need to keep doing it all the time. So, but it is, sometimes we need to use it. And of course, encourage dune growth and dune restoration. They are great defenses. So solution 2.5, it's basically using nature-based solutions. So instead of building big seawalls, let's work with nature and let's build living seawalls like oyster banks or increased mangrove coverage that have additional benefits, not just protection, but also additional ecosystem services. And then lastly, of course, is we need to use evidence-based planning. So that kind of like links back to that first solution where we need that evidence, and then we need to use that evidence on our future plans. And that's, I cannot overemphasize that. So if there's a place which is prone, erosion prone, we shouldn't be building there. That's very easy, and we should be applying that. Because, and let me just finish with this quote I really like, which kind of like puts everything into context. And the beach is dynamic and it changes. And we have these cycles, these ends of cycles, and then longer term climate change. And all of these cycles, really complicated. And the beach will change. That's on the nature of that system. And it's a complex system. So sometimes we cannot even predict what might happen, especially on the longer terms. But that's not the problem. The beach moving is not the problem. The problem is when we as a society want that to stop, and we want to build on top, and that to not move. And we want our beach views, and we want to have, you know, step from the beach or all of those other things, which I perfectly understand. I mean, I live by the beach, by the way. So I'm not kind of, I live 30 meters above the ocean. I wouldn't live anywhere below that. But I live quite close to the beach. Like, I get it. Like, I go to the beach all the time. Like, but we need to understand that it is a dynamic system, and we need to respect that. So we cannot expect the system stopping because we want those beach views. So we need to enforce that planning, and we need to make sure they are based on evidence and not on some political agenda or whatever else. So that's basically the three solutions I have, and I hope you've learned something about La Niña and how it has changed our goals the last 3 years. So thank you for that.
Thank you very much, Xavier. We'll go straight to questions. Do we have any on chat, Lillian? No. Okay, well, if you are on Zoom and you wish to post a question, please do that on chat. Otherwise, over to the floor here. Who has a question? At the back. Okay, Ralph.
Are you familiar with Moffat Beach at Caloundra?
Very much, yes. Not very much, but enough.
One of the landowners on the foreshore there has armored the front of his property with a large quantity of rocks. Would you care to comment?
So I haven't been to Moffat's for a long time now, but I am aware that a lot of that seawall got undermined during the last few years, and a lot of that collapsed. Of course, when we build walls, they are highly effective protecting the infrastructure behind them, but it usually creates one of these positive feedbacks where you just increase erosion. And the problem with that is that it doesn't matter how well you design your seawall, it's going to get undermined unless you keep maintaining it, which is quite expensive. So you might be pushing that for some years, depending on how much money you have. But eventually, you'll have to leave that to the whole ocean energy, and that will collapse as well. So at the end of the day, putting seawalls, I think it's counterproductive because, and this is a very personal opinion, because one, they will potentially increase erosion on front of that seawall. So you are losing a public resource, which no one wants. Secondly, eventually it will get undermined, collapse, and lose its protective function. So at the end of the day, you will also lose anything behind that seawall. So at the end of the day, it's just a very temporary fix. It's a band-aid fix, quite expensive, and to the expense of the public. And that's the worst part of it. Like, a lot of people up New South Wales are also pushing towards seawalls. thinking that that's the solution to protect their very expensive properties. But they need to understand and look at this through a systems approach, where it's what you do here will have impacts there. So you need to think about that. And I think that's where government should step in and regulate. And that's where I'm going, like, evidence-based planning should be imperative. And local councils and states should be making sure that their plans, because there is a very thorough management plan, both from the state and from local councils, but they should be enforced and enforced so people stop doing those type of short-term fixes which don't benefit anyone.
So how far north is the range of this effect, and how far south in Australia?
That's a very interesting question, because La Niña basically ranges throughout the whole East Coast, but the coastal response is quite different. And everywhere north, because the Great Barrier Reef is there, has a very different response than south of here. And then eventually, kind of like the coast turns a little bit more, so we kind of like are on this orientation, and then it turns a little bit more to kind of like the southwest. So again, that change in direction changes a lot. So if you were to coarsely have regions where the coastal will behave differently, I would say that you have a northern region where you have the reef, then you have Southeast Queensland, where this is what I've gone over, and then you have that kind of like New South Wales coast, which again, it's quite different. So, for example, from what I know, New South Wales, except for the Newcastle area, it hasn't experienced as much erosion as we have experienced. And even the Gold Coast, to my understanding, they haven't experienced as much erosion as we have experienced up on that kind of like Sunshine Coast stretch. So it depends a lot on the orientation of the shoreline and also what's out there. So the islands and the reef will make a huge difference on how the coast reacts. But the effects of La Niña are basically very similar all throughout the eastern board.
Yeah, in relation to La Niña in Peru that you talked about earlier, it's my understanding there's a cold ocean current that moves up the coast of South America on the west coast. That wasn't enough to ameliorate the effects of La Niña.
So La Niña on the South American coast is actually gets colder. So El Niño is the reverse. So El Niño is like La Niña for us here.
Yeah.
But that's a great question, because when I saw this event just a few weeks ago, where the temperature just soared, like the ocean temperature just soared, even though it's been colder than average with a La Niña going on, my first thought it was like, that is climate change, right? That's just climate change. That has been kind of like being mitigated by this triple La Niña. And then as soon as La Niña relaxed a little bit, it just went up. So but that's not based on evidence. That's just a hypothesis, right? But I do think, I do think that there is evidence pointing towards kind of like these La Niña events making things a little bit cooler. But as soon as they go away and we go into El Niño, then especially for the South America, the temperatures will rise even more. So we will see more of those extreme conditions. But yeah, just to put that in context, this has been the first time, at least in 50 years, of the coast of South America that they've had that type of coastal El Niño so early on. So this is very uncommon. It took everyone for surprise, like no one was expecting that. And right now, they're having like 30+ degrees, which is very, very uncommon for this time of the year. especially because El Niño hasn't been officially declared, and usually El Niño kicks in later in the year. So yeah, my take is that these events are just kind of like interfere or combining with an underlying trend of warming conditions due to climate change. That's my take.
Well, it's hear you talk. I wished I had heard it 15 years ago, because you put up a slide on RV and I saw my place. And that's where I am. In the high rise, and we're just about to authorize a $3 million wall in front of us. We have to do a wall, not rock, because we haven't the space between the edge of the building and the council land. We can only go vertical. So it's a 7-meter, $3 million wall, not only in front, but down the side to protect us, because council's on one side and they won't do anything. And another landholder's on the other side, and he won't do anything. So it's no use having a 7-story apartment without a wall. Thank you anyway. Fantastic. Obviously, you're not going to move down there.
No, the case of Narrabeen is very, very interesting. For one, it's probably one of the areas which has been has the longest record of studies around the world. That it has 30 years plus of data. So, so if we know, as in coastal scientists and engineers, if we know a place is Narrabeen. So, and even though we have all of this knowledge, when it comes to actual impacts and actions, there's nothing you can do, because you have all of that infrastructure there, including not just the apartments, but also the roads. And something else was there, but anyway, it has to be protected. It has to be. There's no way, and there's no way to move. So you have to go extreme and put on these type of solutions, and that's just a legacy of bad planning. So this is just 40 years or 50 years of bad planning, but planning that wasn't like. I'm not blaming planning. I'm just saying that back then, we didn't have that information. We didn't know better, and that's okay. Now we do. So now it's when we should be implementing all of that knowledge into action, and we shouldn't be allowing new developments. So in 40 years' time, we don't have to deal with those type of issues. We put a lot of effort, like a lot of pressure on private people, like they actually have to pay for those walls. So I understand that that's a shared cost, but most of that cost is falling onto private owners. So again, that's a very contested kind of like space, and we need to avoid that into the future, because the other part of the equation, I guess, is that things are getting worse. So we cannot rely on previous kind of like, oh, 50 years ago, we got a cyclone or two every 20 years. We know now that the chances of these events happening more and more frequently are higher. So we need to be prepared for that. So a lot of people get confused, I guess, with this type of talk, and they think I'm kind of like all gloomy and doomy, but I don't consider myself gloomy and doomy. I think I'm just kind of like ringing the bell right now to avoid those gloomy and doomy kind of like scenarios in the future. Like, I have kids and I want them to grow up on the beach and go surf on a sandy beach and don't have to be like climbing a 7 meters wall to go for a surf. So yeah, I think that this is the time that we need to take action, and we need to start applying all of this knowledge that we have to avoid these future issues.
How far back from the beach are you? Is your apartment building?
Right on the beach.
Beautiful place.
I didn't build.
Yeah, but you mentioned the longshore drift due to the La Nina pushing sand northwards roughly, and facilitated by the Niña storms. I was just wondering if there's a net northward drift. That means that suggests there are going to be beaches that have no sand left eventually, which will be, I imagine, impossible to remediate. And I'm not sure how far, I imagine some are in worse condition already than others, but is anyone thinking about this?
I hope so. And this is a really tough question, and this is a conversation I think everyone has to have right now, all the stakeholders, because yes, that's where we're heading, and we know that. So what can we do? And I mean, like, on my very cynical eyes, I guess, and very removed position, I would say that we need to retreat from those areas, and we just need to go somewhere else. But that's way easier said than done. I mean, if someone comes tomorrow and tells me that I have to move, I probably won't move. So it's not easy when it comes to your property. It's a very challenging issue. I mean, like, and we are still on a lucky position, I guess, here in Australia, because I've heard from places like around the UK and the States, they actually quantify how many houses fall onto the sea each year. So it's not about, oh yeah, the beach eroded like 10 meters or 20 meters. They were like, yeah, this year we lost like 10 houses, right? And so North Carolina and places around like the Devon coast, and I think they lose houses all the time, and they're losing more and more houses, like full-on houses just falling onto the ocean. So I think we need to avoid that. And I think one way of doing that is actually planning a retreat. And the earlier we do that, the less expensive it's going to be, not only in economic terms, but also like in emotional terms, I guess. So yeah, I mean, first we need to stop any development on those areas, and then slowly buying back, moving away. It's the way forward, I think. Not easy, but I think that's a conversation we should be having.
How do the groins, for instance, in the Tweed River, they've got the huge rock walls coming out. How does that affect the moving sand?
Huge effect. So big that they had to actually bypass the sun. So they will dredge the sand from the south, and then they just have this pipe and they just put it on the north, because otherwise, like all of that coast around, especially Kiva, became from, you know, like a lot of sand to nothing, a lot of erosion happening. And then they bypassed too much sand, so they had too much sand, so they had to pull it back. But I think they've managed a good equilibrium. But of course, every time you do something on one place, it's going to have those downdrift effects. So if we look at that as a system, then we understand that, and then we can mitigate and fix those issues like they've done on the tweets, which is, I believe, quite efficient, quite expensive too. So even though it's ideal, you cannot put that on every river and creek. So yeah, that might be an issue as well, the costs. Yes.
Are there any more questions?
Yes,
From that?
yes.
I'll just, before that, I'll just read out a couple of comments from Zoom. So from Damien Kelly, thanks very much for an excellent presentation. And from Maria, fantastic presentation, thank you.
Thank you
We
all.
might make this the final question, but of course there's always time afterwards during supper. So I'll go to the back here.
This is not a trick question. But I'm thinking in terms of the geology of all this. How far back would you estimate the sand has been moving from the south up to the north? And has it ever moved the other way?
So it is a tricky question, because my brain suffers with like geological times, like, and that's why I'm not a geologist and I'm a geographer. I always struggle with, like, I cannot think like in thousands of years or millions of years, but I do understand that net northerly drift of sand has been happening at least from the Holocene, I guess, probably before, if I'm, yeah, but it's been happening for a long, no, sorry, way before the Holocene, because like the Kulula sand dunes, they've been formed since the Pleistocene. So it's been going on for a long time. And that's a net drift. But of course, you have reversals, like local reversals all the time. So even, and especially with La Niña changing that wave direction, you will get those reversals. So that's quite evident on these open beaches, like the one we're seeing up here, where, you might have these kind of like northerly drift, and then as soon as you get more easterlies or northeasterlies, you get that reverse, and the sun starts traveling south. So it's quite dynamic, but on average, it will move. So the fate of a sand particle starts on the granite belt, and eventually, thousands of years later, it will make its way up north all the way to Gary, and then eventually goes offshore to a deep water canyon and goes away. But in the shorter terms, it will reverse, and that's that you can observe that on a year-to-year basis as well. So again, that's tricky when it comes to management, because especially when you are trying to implement interventions like groins, which rely on this net transport, and suddenly you don't take that into account, and a groin doesn't become as efficient. An evidence of that is that middle groin on Nusa. So on Nusa, you have a groin on the river to the north, and then a middle groin. I constantly argue that middle groin is not that efficient. It doesn't really trap much sand. It does trap sand, but not as much as it should. I think that groin shouldn't be here really because of these reversals as well. So there's not So to answer your question, it's a net northerly drift, but you have localized reversals of that drift as well.
I think we might let Xavier have a bit of a break and go to our thanks. So tonight, Xavier has shared with us some of the complexities of those links between ENSO, La Niña, El Nino, and our coasts and what's happening to them. And particularly of interest, the very local examples which he has been able to share with us tonight, from the Sunshine Coast down to some of the other areas which we're all familiar with. So thank you very much, Xavier, for a most interesting and informative talk this evening. Okay.